have 6 years of
This
IT experience.
conference will now be recorded.
Yeah, so I have 6+ years of IT experience, and so I have experience of 4+ years on the big data or Hadoop administration. So I have worked in the different companies, different MNCs like TCS, Verizon. So now I'm working for one of the banking MNC client. This is about myself. And just can you give me a brief introduction about yourself?
I have total 5.5 years of experience as a DB to DB administration.
Oh.
So currently I am working in HCL Technologies in Bangalore location.
Oh. Others? Okay. We're done. Okay. Okay, sure. Okay. So are you aware of Hadoop big data?
Not much more, little bit basics.
Okay. So basically, so as part of today's session, we'll go through the introduction to the big data. Like we'll go through what is big data and what is Hadoop. So why the big data has emerged as a one of the great technologies into the one of the latest technologies. So we'll go through what is big data and what is Hadoop. So what are the 3 V's of big data and why the companies are using Hadoop? What are the different companies that are using Hadoop? So Hadoop components and architecture, and what is meant by Hadoop cluster, the Hadoop distributions. So usually what are the roles and responsibilities of the Hadoop administrator, and also we will go through the course content. So what is big data? So basically big data is a term that describes the large volumes of the data. So that is both the structured and as well as the unstructured. So it's not amount of the data that is important, it's what organizations do with the data that matters. So as you are working on the DB to DB, so can you just ask me, can you just tell me like, is it possible to keep unstructured data in DB2, like the JSON files, XML files?
No, only structured files we can see.
And also, is it possible to extend, for example, so let us assume you install DB2 server in one machine, and let us assume the server's capacity got reached. So usually what will we do? So we will insert one more hard disk, and then we'll try to increase the capacity of our DB2 cluster. So my requirement is like, so suppose instead of putting hard disk in a single machine, so I will install the DB2 in another machine. I will join them together. I will make a DB2 two-node cluster. Is that possible in DB2?
No.
So it's not possible. It's a completely limited to a single server.
Yes.
So that's the problem with the data. So because as the digitalization, as the digitalization technology has been emerged nowadays, the data is coming from almost all the domains. So the data is coming from many of the domains like IT domain and telecom domain, finance. So all the domains they are generating the data, and this is the huge data that is generating into the environment, IT environment. And we need a mechanism to keep the data. So we need a mechanism to keep the data or to store the data and as well as to process the data. So such mechanism is called big data. So as the data that is being generated is huge, we don't have any right mechanism to store the data and as well as to process the data. So such mechanism is provided by the big data. So here the problem is the big data is not any solution. So here the big data is just a problem statement. So big data is a term that describes the large volumes of the data, both structured and as well as the unstructured. And it's not the amount of data that is important, it's what organizations do with the data that matters. So here I got a lot of data, and using the big data solutions, for example Hadoop, I'm able to keep the data. So what I'm doing with the data? So am I generating some insights from the data? So that's what important. So we need to generate some insights from the data, we need to create some insights from the data. So that is the processing of the data. So keeping the data in our servers is that doesn't produce any output. So we need to process the data. So do we have any other processing mechanisms to process these huge volumes of the data? No. So that's why big data also provides a mechanism to process these huge volumes of the data. So big data provides both the data storage and as well as the data processing. So the problem statement is a big data. So big data is not any solution. It's just a problem statement. And what is the problem? What is the solution to this problem statement is a Hadoop. So Hadoop is an open source software framework for storing data and running applications on clusters of commodity hardware. It provides massive storage for any kind of data, enormous processing power, and the ability to handle virtually limitless concurrent tasks or jobs. So Hadoop is an open source software framework. So Hadoop is a software which is designed to solve the issues with the big data or huge volumes of the data. And it's an open source software for storing the data and as well as running applications on clusters of the commodity hardware. So it performs two jobs. One is the storing the data and also it processes the data that got stored in the Hadoop cluster. And it works on the clusters of the commodity hardware. Commodity hardware in the sense like the normal desktops or laptops also. The commodity hardware in the sense like the cheap hardware. So usually for the applications for the high end for the applications in the real time production systems, we use the high end servers basically from Cisco or any other some other hardware provider. Cisco, IBM, HP. So we purchase the servers from them and we set up the servers. We set up our applications in the servers. So these are the high-end hardware. So if I want to set up Hadoop cluster, if I want to practice it, I don't need any such high-end hardware. I just install this in a commodity hardware as well. It provides massive storage for any kind of the data. It provides massive storage for any kind of the data. So any kind of data in the sense, if it is structured data, unstructured data, or semi-structured. So any kind of data can provide. And enormous processing power. So whatever the data that is, and so whatever the size of the data that is, it is able to process the data and ability to handle virtually limitless concurrent tasks are. So it basically virtually it performs a limitless number of the tasks and as well as the jobs. So nowadays the data is being generated so from almost all the systems like social website, especially from the social website, the data is getting generated here. So pictures, videos, IT systems, cell phones, transactions, and almost from all the domains the data is being generated. Basically there are three V's of the big data. So volume, variety, and as well as the velocity. So volume means, so for example, if I take any RDBMS server, for example, MySQL or Oracle, any RDBMS server. Sorry. If I take any RDBMS server, so just RDBMS server's purpose also to keep the data, to store the data, and as well as to process the data. And when it comes to the volume, so what is the storage capacity of the RDBMS servers? So what is the storage capacity of the RDBMS servers? So that is up to a particular limit. So that is limited to the hardware, that is limited to the hard disk that we put inside this Oracle or the DBMS servers. So there is a limited storage capacity is available for the RDBMS servers. For example, let us assume I am running some MySQL server and MySQL server capacity is 1 TB. So let us assume today I'm going to keep 1 TB of the data into the MySQL server. So tomorrow again I will get 1 more TB of the data. Then my storage capacity is already completed. Then what I have to do? Again I have to shut down my MySQL server and I need to put 1 TB of the hard disk. So that is inside a single server, I'm keeping 1 TB of the hard disk. And then again I start the MySQL server, so that will be, it will become the 2 TB. MySQL server storage capacity will become 2 TB, and then I'm going to keep 1 TB of the data. So again, after 2 days, if I'm getting 1 more TB of the data, then again I need to follow the same procedure. So that means every time I need to insert the hard disk into a single server. So that is virtually there is always a limit to keep the such data inside a single server. So in case if I want to extend it, then I need to purchase the multiple servers and I need to make it as a single hard disk. So I need in the new servers also I need to place the hard disk. So there is always a limitation when it considers to the, when we consider as a volume. And also when it comes to the processing, so basically these RDBMS servers, so they are very good to process the data up to TBs. So some RDBMS servers, they are good to process the data in GBs. So some are good in processing the data in a TBs. For example, Teradata is good in processing the TBs of the data. When it comes to the petabytes of the data, for example, if I have such huge data, petabytes of the data, and I want to process it, then RDBMS servers they are not efficient. So they don't provide the optimal performance, or they don't provide the good performance as we get when we process very less data. So that is about the volume. But when it comes to the Hadoop, so if I install Hadoop, so for example, if my input data is 1 TB and I have installed Hadoop in one machine, so I stored this 1 TB data into the Hadoop, and tomorrow also I will get 1 more TB of the data. Then what I will do, I will just keep 1 TB of the data. I will just install Hadoop in one more machine. It's not any hard disk. I will buy one more machine and I will install Hadoop in that new machine and I will join these two machines together. Now I have made 2 node Hadoop cluster. So now it becomes 2 node Hadoop cluster. Now I can keep 1 more TB of the data into the new machine. Suppose after 2 days, if I get 1 more TB, then again the same procedure. So I will purchase new machine, install Hadoop on top of it, set up a 3 node Hadoop cluster and keep the new 1 TB of the data. So like that, my data is getting distributed in a parallel way. So if you compare the previous scenario, in RDBMS servers, I am keeping the hard disk in a vertically. So inside a single server, I am keeping the hard disk. So that is called a vertical scaling. And here, and what I'm doing, I'm just installing the Hadoop in new machines, and I'm joining the new machines to the existing Hadoop cluster. So this is the horizontal scaling. So like that, I can put n number of machines into the Hadoop. Is that clear, Srinivas, so far?
Yeah, clear.
Yeah. And one more way is the velocity. So there are 3 types of the processing. So batch processing, near time, near real time, and as well as streams. So both are same. Near real time and streams both are same. So so Hadoop is basically designed for the batch processing. So batch processing in the sense like the traditional data warehousing kind of tools that they process, right? So Hadoop is not any database. Hadoop is a data warehouse. So that means I can keep the data and I can process the data, but I still cannot use the Hadoop as a database. It's a data storage and as well as a data processing tool. Hadoop is basically designed for the batch processing. So the difference between batch processing and real-time processing is, so in the batch processing, what we do is that we wait, so we schedule our jobs to run at a particular time. So for example, let us assume my company CEO, he daily comes to the office at 10 o'clock and then he will conduct some meeting or and then he sees some dashboards like what is the sales report in the last 24 hours like that. So that means he is seeing the sales report in the last 24 hours. So that means, so whatever the data that he sees in the on top of the dashboard, so in the back end that is being processed as a 24 hours data. It's not a real time data. Then what will happen is, so basically they schedule the jobs at, for example, if he comes to the office at 10 o'clock, basically they schedule the jobs to run at some 6 o'clock in the morning. So the previous day 6 o'clock to the today 6 o'clock. So whatever the data that is there in this 24 hours, it will be processed. So that means I am processing the data at a particular time. So that means I am not processing the data whenever it generates. I mean, whenever it gets generated. I'm just processing the data only at a particular time when I wanted to process. That is called a batch process. And real time or near real time processing is, so whenever the data is generated, it will be automatically processed. So for example, if you make any bank transactions, for example, NEFT bank transaction. So NEFT is a batch process. So that means they schedule this NEFT jobs some particular time, 2 hours, 4 hours like that, and then only it will be processed. And IMPS is a real-time processing. So whenever we do any transaction, it will automatically be processed. So that is to the velocity, and Hadoop is basically designed for the batch processing. It is not designed for the real-time or near real-time. And also there are some Hadoop ecosystem tools. So there are some tools that are generated on top of Hadoop. We can use them and we can do the real-time or near real-time processing. Variety. So any RDBMS server, so basically they are designed for processing the structured data, kind of SQL kind of data. And some RDBMS server, they are still allowing to process some JSON related data, XML related data, but not all the RDBMS servers. So I'm unable to process all kinds of the data using any RDBMS server. So basically they are designed to process the structured data. If I have XML, JSON, PDF files, I cannot process them. And if I have image, if I have video, if I want to process them, I cannot do it. So using Hadoop, we can do any kind of processing. Structured, unstructured, semi-structured, any kind of processing will be done by the Hadoop. So that is called variety. Why are we using Hadoop is, so basically one of the advantages with the Hadoop is it overcomes the traditional limitations of the storage and compute. So in the traditional RDBMS servers, so the problem is they are not scalable. They are scalable only in the vertical scaling. So that is inside a single server, I need to put multiple hard disks to get the storage capacity. And inside a single server, I need to extend my RAM. I need to extend my RAM to get the memory capacity. But when it comes to the Hadoop, as it is a horizontally scaling, so whenever I add the new machine, I get the storage capacity and also I will get the memory capacity. So it overcomes the limitations of the traditional storage and as well as the process. So one more advantage is it leverages inexpensive commodity hardware as a platform. So I don't require any high-end servers if I want to keep the data and I want to process the data. So I can take the normal commodity hardware types, the cheap hardware types. I can buy the cheap hardware types from any vendor, hardware vendor like IBM, HP, and I can set up the Hadoop cluster. So I don't need any high-end servers to set up the Hadoop cluster. And the scalability is it provides the scalability from 1 to 4,000 servers. So 4,000 is the limitation in the Hadoop 1 version. So Hadoop has two versions, Hadoop 1.x and Hadoop 2.x. So currently we are using the Hadoop 2.x. Here inside a single Hadoop cluster, I can put maximum of 10,000 nodes. So in a single Hadoop cluster, I can add 10,000 machines to make it as a Hadoop cluster. And it's a low cost open source software. So Hadoop is a completely open source software. So I don't need to pay even a single rupee to anyone for using the software. So there are so many companies. So nowadays, all the companies they're using the Hadoop. So, but these companies are using for different operations. For example, for the search, Yahoo, Amazon, they doing, and for the log processing, the Facebook, Yahoo, for the recommendations, Facebook, LinkedIn, data warehousing operations, Facebook AOL, for the video and image analysis, New York Times, email. So almost all these domains they are using the Hadoop. So basically, Hadoop has two components. One is the HDFS and MapReduce. So in a single word, if I want to describe the Hadoop, so Hadoop is a distributed storage and distributed processing. So here the keyword is a distributed. It keeps the so just like your RDBMS server, it also keeps the data and it also processes the data. But the difference between RDBMS and Hadoop is a distributed. So basically, they are not distributed, but Hadoop is a distributed. So it has two components. So one component is HDFS, which is used for the storage platform. So it provides a distributed storage platform. And another component is a MapReduce, which provides a distributed processing platform. So this is a high-level HDFS architecture. So I'm not going to deal it today. So I'll talk about it when it comes to the HDFS architecture. But on a high level, so your HDFS will have the two services. One is the name node service and one is the data node service. So the name node is a master service and data nodes are the base service. So that means whenever you put any data into your Hadoop, so basically this data will be stored in a data node. So usually in a single Hadoop cluster, I can put multiple data nodes and I can put one name node. So as the name node is the master service, it just directs or it just controls the data node. So whenever you put some data, the data will be distributed into these Hadoop data nodes in the form of the HDFS blocks. So Hadoop has a concept called blocks, and by default the block size is a 128 MB. So for example, if you put 1 GB file into Hadoop, so your 1 GB file will be stored as a 8 blocks. 1 GB divided by 128 MB is equal to 8 blocks. All these 8 blocks they will be distributed into the multiple data nodes. And who directs or who controls the distribution of these blocks to the data nodes is a name node. So there's a name node is the heart of your Hadoop cluster. So it has that information about the data nodes and the data residing in this data nodes, the blocks, the files. So all this information it is being maintained in the name node. So your name node it doesn't keep your actual data. It keeps the information of the data or it keeps the data about the data. So that is we call it as a name node metadata. So these are the two main components, but I will in detail discuss about the architecture later. So what is meant by Hadoop cluster is this addition of the slave nodes. So slave nodes in the sense data nodes. The addition of data nodes to store and process the used data. So usually in a data center, it will be looks like this. So basically in the data centers there is a concept called a rack. So basically a rack is just like some kind of the almara. If you can visualize it, it just looks like some kind of bureau almara. So inside a rack, I can put the multiple servers. So usually, in one of the racks, I put the name node, and in the either in the same rack or in the other different racks, I can put the all these data nodes. All these data nodes, or sorry, all these racks. So for every rack, there is a switch, and using the switch, it will talk to your network. So all these switches they're interconnected to the network switch, and this network switch again it will talk to the internet. So there are some popular distributions. So that is the popular vendors who are providing the Hadoop. So Apache, Cloudera, Hortonworks, Mappa, Pivotal, IBM, Imagine. So these are the popular vendors. Out of them, the open source is Apache. So Apache Hadoop is a open source software which provides a Hadoop software without any cost. It provides a Hadoop software with free cost. So I can go to the Apache website and I can download the Hadoop and I can set up the Hadoop cluster. I don't need to pay even a single rupee for that. But the problem is, so for example, let us assume I'm going to set up 100 node Hadoop cluster, 100 node Hadoop cluster. So let us assume I will be installing the data node in 99 machines and one machine having the name node. So if I want to install like that, then what I have to do, in each machine I have to log in and then I have to download the Hadoop software and then I have to install the Hadoop software. So that means it's a manual effort. It's a manual work. So in every machine I need to log in and install it. And also, so for example, if in any of the machines, if the data node goes down, so the data node process goes down, I don't have any common monitor mechanism. I don't have any common monitoring to monitor the process, whether they are running or not. So the common monitoring, so the centralized monitoring and as well as the centralized administration is not available in the Apache Hadoop. So Apache Hadoop is only used for the development. If you want to develop some code or testing, practicing, like, and nobody will use it in the production. So in production, so basically, most of the companies they use either Cloudera Hadoop or Hotanox Hadoop. So it's not different from the Apache Hadoop. So basically, as the Hadoop is a open source software, so these guys also downloaded the Hadoop software and they developed some tools on top of it and they automated it. So they provided some tools, they provided their individual tools to get the centralized monitoring and as well as the centralized administration. So when it comes to the Cloudera, so the tool we call it as a Cloudera manager. If I want to install Hadoop cluster, if I want to set up 100 node Hadoop cluster, then what I will do is that I will just install Cloudera manager in one machine and then I will start the Cloudera manager. It will give me some web UI. So in the web UI, I give the list of the host name of the Hadoop. So I can give at a time I can give the 100 machines. So it will install the Hadoop in 100 machines at a time. And also I can using the web UI, I can monitor the data nodes are running good or not. Name node is running good or not. Like I can monitor the service. So similarly in the Cloudera, so there is one more vendor called Hotanox. So Hotanox provides a software called Ambari. So it is equivalent to your Cloudera manager. So here also I install Ambari in one of the machines and it will give me some web UI. In the web UI I give the list of the host names and I can set up the Hadoop cluster, which can be further monitored and as well as administered using the same Ambari UI. So these two are the two popular vendors, Cloudera and Hotanox. And the other vendors, Mapr, Pivotal, IBM, Amazon, so these are not so much popular as these two. So if you go to any organizations, most of the organizations, they may use either Cloudera or Hotanox. So just learning any of these tools is a sufficient. So you don't need to learn both. We can learn any one. So that's a sufficient because both these tools they are almost similar. So what are the Hadoop admin roles and responsibilities here? So he has to design the capacity planning and designing. So like how many Hadoop nodes that I require in a Hadoop cluster and what should be the storage, what should be the capacity of the each node, like how much storage is required, how much memory, like that information. And so once he gets the machine, then he has to set up the cluster. So it can be Cloudera or Hotanox. So that can be decided based on the client. And also whenever any new versions are released, he has to perform the upgrades. Troubleshooting, so if any of the job gets failed in a Hadoop environment, so he has to troubleshoot. And performance tuning, If any of the job is failed, or if any of the job is not performing good, if it is running slower, then Hadoop admin has to enable the performance tuning and automation. So he has to return he has to write some scripts to automate any process wherever it is required. So Hadoop, so as we are going to keep huge volumes of the data into the Hadoop cluster, so keeping the data secured is also a very important task for the Hadoop admin. So there are some security tools that are developed for the as part of Hadoop ecosystem tools. So providing security to the Hadoop cluster is one of the activities for the Hadoop admin. So Linux activities. So Hadoop is completely developed on the Linux. So it is better. I mean, Hadoop admin should also have some knowledge on the Linux and any development support. For example, usually in the production clusters, developers they won't have any access. So if they want to run any command, so basically they will give the commands to the Hadoop admin and they will ask the Hadoop admin to run those. So like that. So these are the typical Hadoop admin roles and responsibilities. When it comes to the course content, so I'll just talk about the introduction to big data and Hadoop components and HDFS architecture, and then AN architecture and Hadoop 1 versus Hadoop 2. App reduce job flow and word counts of Linux command, Hadoop single mode setup, Hadoop ecosystem components. One is Apache Hive, Apache Pig, Root, Bloom, Fuji, Kafka, and introduction to NoSQL DBs, HBase, Hadoop multi-node cluster setup, Hadoop commands explanation, Hadoop Autonomous cluster setup, automated way, introduction to high availability and HS setup, so Kerberos, which is a security tool, Kerberos setup, Ranger, Knox, these two are again the securities, and schedulers, creation of ANQs, Hadoop performance tuning and optimization, Apache Spark and Sage. These are the topics that I'm going to. So as part of this. Yes, do you have any questions, any doubt?
Yeah, this is the course content, right?
Sorry?
This
Sorry?
is only course content, right?
This is the course content. I mean, it is a like a high level course content, but as part of the sessions, I mean, some new topics also will come. These are like, suppose if it comes to
Okay,
the
okay.
Ranger, I said introduction to the Ranger. So in the again, the Ranger has some other components called Ranger KMS, which performs encryption of the data. So just these are the high levels. So there are there are also subtopics that.
Okay, okay.
Any more questions?
So how much duration the course?
The duration would be some 35 hours, 35 to
Okay,
40 hours. Yeah.
okay. So currently you are using 2.x something.
Yes, yes, 2.x. Nobody using 1.x
Okay,
in real time. Everyone using 2.x.
okay, okay, okay. Is it practical how you are showing that only 1.x and also 2.
Yes. Sorry?
Practically you are going to show 1 and a 2 only or only 2.x.
Yes, only 2.x. I won't show 1.x, but I will tell what is the difference between 1.x and 2.x because that's your interview question. But everything is a practical. I will show in live. So I will show setting up the Hadoop cluster and Hadoop ecosystem component and everything.
Okay,
Okay.
okay. Is after course the real-time project is there?
Yeah, yeah. So I mean, I didn't include this. So after all this session, I have prepared a POC. So
Okay.
that is yeah. So I have prepared. So what are the tasks that are need to be performed as part of the POC? Just go through the just prepare the POC. So once if you successfully done the POC, and even though you don't have any real-time experience in Hadoop, so whatever the issues that you face while doing the POC, you can tell blindly in the interview.
Okay. Okay. Fine.
If anybody asks you like in interview, so what are the issues that you faced so far? So whatever the issues that you faced in while during the POC, yes, you can tell them because I have
Okay. Okay.
designed the POC in a real-time environment.
Okay. Okay. So first you are going to teach as storage, and then it go to
Yes. In
like
the next session, I will go to
MapReduce.
Hadoop components and HDFS.
Okay. Where is the general node and Zookeeper is not included?
That will come in a HA, high availability. So which comes
Okay.
under this one, introduction to high availability and HA. So
Okay.
that's why these are all high level topics.
Okay. Okay, Raghav.
Mm. Thank you.